Okay, so we've got a typical word problem here. Poorly written, of course, but it's what we have to deal with. So let's talk about how to work our way through it. The word problem says that the students in Sean's class predicted that if they each rolled a number cube 90 times, then they would roll the number 5 once for every 6 rolls. If each student completed the experiment, which result best supports their prediction? So let's just step back for a minute and talk about a number cube, right? A number cube is, of course, a dice or a die, and it has 6 sides and 6 numbers, and as long as it's fair, of course, right, every side has an equal chance of turning up when you roll it. So that means 6 sides, right? The number 5 then has a 1 in 6 chance of turning up. So if we scale this up to 90 times, we can kind of predict about how many should turn up. And that's what they're saying here. Based on this prediction, right, how close are we to, or what would we have to roll in order to be very close to this prediction? If we're saying the number 5 will turn up once for every 6 rolls, that seems to match the theory here. We're saying it right here in the fraction, 1 for every 6, then how many should turn up out of 90? That would be a nicer way of asking this question. So essentially we're solving this proportion. How many times does 6 go into 90? Well, I know that 6 times 10 is 60, and 6 times 5 is 30. And if we put those two together, we get 15. So 6 times 15 is 90. So 1 times 15, right, would equal x. So if we were exactly right, if a 5 did turn up exactly once for every 6 times, then that means it would turn up 15 for every 90. So if they ask you a question saying, which result best supports their prediction, what they're trying to say is, based on the theory, this should happen. You should get exactly 15 rolls, but you're not going to get that. You're probably going to get, I mean, you could get that, but you're probably going to get something close to it, but probably not exactly 15. So if you're looking at a bunch of fractions to compare to this, pick the one that's closest to 15 over 90. For example, if they picked 16 over 90, that would be much closer to their prediction than something like 20 over 90. Right? These are not equal, sorry. But here, 20 over 90 is even further. And the more distance there is between this numerator and 15, the further off their experiment would be from the actual results, from the actual theory, not the results. Right? So their results here would be quite far from this. Here, with 16, it would be right next to it, would be very close, and it would validate it. So essentially, again, you're just picking the numerator that's closest to this numerator right here. All right, hope that helped.